Hello everyone. In the previous video, we have evaluated the nth order derivative of e raised to power ax and ax plus b raised to power m. In this video, we will see how to find nth order derivative of some more special and standard functions. Let's see how to find nth order derivative of logarithmic function log ax plus b. For that, we will differentiate this function once with respect to x to get derivative of log ax plus b, which is equal to 1 over ax plus b, and again derivative of ax plus b is equal to a. So derivative of this y with respect to x is equal to a over ax plus b. But we need to find nth order derivative of y. So what we will do, we will differentiate n minus 1 times this first order derivative, which will be equal to nth order derivative of y. So n minus 1 times differentiation of first order derivative a over ax plus b is equal to a into n minus 1th order derivative of ax plus b raised to power minus 1. We will apply this rule to find n minus 1th order derivative of ax plus b raised to power minus 1. We always apply this rule whenever this m is negative. Only difference is here the formula is of nth order derivative. We will replace n by n minus 1 in this formula, and that will be the formula of n minus 1th order derivative. So only changes to be made are replace n by n minus 1 and m by minus 1. If you compare these two terms, the difference is that instead of n minus 1 is written, and in place of m minus 1 is written. So we will apply this formula and we will write n minus 1 in place of n. So what we will get, this is equal to a, and next term is a raised to power n minus 1. A raised to power n minus 1. And as I have mentioned that in place of m, you will write minus 1. So it is minus 1, minus 1, minus 1, minus 1, minus 2, up to minus 1 minus, whenever we have nth order derivative, we subtract n minus 1 from m. When we have n minus 1th order derivative, we will subtract n minus 2 from m, which is minus 1 over here, into ax plus b raised to power minus 1 minus n minus 1, because here we don't need to find nth order derivative. We are finding n minus 1 order derivative. So in place of n, we will write n minus 1. And this is equal to a raised to power n minus 1 minus 2 minus 3 up to minus 1 minus n plus 2 into ax plus b raised to power minus 1 minus n plus 1, which is further equal to a raised to power n minus 1 minus 2 minus 3 up to minus n plus 1, ax plus b raised to power minus n. If I take minus common out of this, I will get negative of n minus 1 and ax plus b raised to power minus n. How many terms are there? Starting from 1, going up to n minus 1, these are n minus 1 terms. If I take negative 1 common out of these n minus 1 times, I will be getting minus 1 n minus 1 times, which will be equivalent to writing minus 1 raised to power n minus 1. Because I have taken minus 1 common out of these n minus 1 terms, now I will be left with only positive n minus 1 terms. And this negative power becomes positive if I write this term in the denominator. You must be aware with the fact that n factorial is equal to n minus 1 up to 1. Or for example, if I write 6 factorial, this is equal to 6, 5, 4, 3, 2, 1. Here I have n minus 1, n minus 2 up to 1. So I can write it as n minus 1 factorial. So I write it like this, n minus 1 factorial upon ax plus b raised to power n, which means nth order derivative of log ax plus b will be equal to a raised to power n minus 1 raised to power n minus 1, n minus 1 factorial upon ax plus b raised to power n. Let's find nth order derivative of one more standard function, which is e raised to power ax into sine bx plus c. Let's take this equal to y. And I'm supposed to find nth order derivative of this function. First, I will differentiate it once. And you know that when I have to differentiate product of two functions of x, if u and v are functions of x, then the rule is first differentiate u, write v, then write u and differentiate v. Likewise, first I will differentiate e raised to power ax, which is e raised to power ax into a, and write second function as it is, plus first function as it is and derivative of second, which is cos bx plus c, and again derivative of bx plus c will be equal to b. If I take out e raised to power ax common, I will be left with a into sine bx plus c plus b into cos bx plus c. So this is first order derivative. Can I take a as r cos alpha and b as r sin alpha, where r and alpha are constants? What this first order derivative of y becomes in this case? This is r cos alpha sin bx plus c and r sin alpha cos bx plus c. If I take r also as common, it will be sin a cos b plus cos a sin b formula, which is equal to sin a plus b. R is common, and here these values of a and b are used for this a and this b, so that we can combine this whole term into one single term. And you know that when sine of this is angle, I'm taking it as the formula sin a cos b plus cos a sin b, which is equal to sine of sum of these angles. So this is first order derivative. If I repeat the same process again, if I find again derivative of this function, so first order derivative, again differentiation will give you second order derivative. So what is this equal to now? R is coefficient. Again we will apply the same rule. first derivative of first e raised to power ax into a, second function as it is, and first as it is, and derivative of second, again it will be cos bx plus c plus alpha. Now alpha and r are constants, and again derivative of this will be equal to b. R is common, e raised to power ax is common. Again use same values of a and b, which is equal to r cos alpha and r sin alpha. Okay, again we can take r as common, so r square will be here now because we have two r's, and sine of first angle into cos of second angle plus cos of first angle sine of second angle will be equal to sine of sum of these two angles, that means bx plus c plus alpha plus alpha. So second order derivative is equal to r square e raised to power ax sine of bx plus c plus 2 alpha. Can we generalize this now? Now continuing this way, when I will reach up to nth order derivative, the power of r will be n. In all derivative, first and second and up to nth order derivative, e raised to power ax will be as there, bx plus c. In the second order derivative it is 2 alpha, and in nth order derivative it will be n alpha. So this is the nth order derivative of product of e raised to power ax into sine bx plus c, where a, b, c are constant. Particularly r is, what is r now? Let's see. We have substituted a is equal to r cos alpha and b equal to r sin alpha. Can we square and add these two terms? Let this be equation 1 and 2. If I square equation 1 and 2 and add both, what I will get? I will be getting r square cos square alpha plus sin square alpha equal to a square plus b square. Adding square of 1 and 2. So what is r square? Which is a square plus b square. That means what is r? That is under root of a square plus b square. When I divide first and second, so what was first? R cos alpha is equal to a. What was second? R sin alpha is equal to b. If I divide these two, I mean divide 1 by 2, then it will be equal to tan alpha, which is equal to b over a. This means alpha is equal to tan inverse b over a. So now I can sum up again that derivative of nth order derivative of y, which is actually nth order derivative of e raised to power ax sine bx plus c, this is equal to r raised to power n e raised to power ax sine bx plus c plus n alpha, where alpha is equal to tan inverse b over a and r is equal to under root of a square plus b square.